And now let's look at the question. I want you to go straight into question 3. Okay, we are going to do question 3 first. So after question 3, then you will see something different. Okay, question 5, 6, and 7, I have already marked and given comments. You can take a look on your own. All right. So look at question 3. Okay, this question is on forces. Springs are used in a pack as shown below. All right, the arrow shows the way the pack is squeezed at the handles. Okay, so these are the arrows that they're talking about. Okay, to open its grip. Then after Sarah squeezes the pack and releases it, the pack can hold her towel up on the line as shown in the diagram. So as shown here. So explain in terms of forces, how does the spring keep the pack closed? Okay, so this part here, we are talking about forces. Okay, and then actually quite a number of students expressed that they are worried about this. I want to look at your answers now. Question 3. Okay, let's look at your answers. Keith is here. All right, so take a look. They want you to explain in terms of forces. How does the spring keep the pack closed? All right. So Cassandra, you're not explaining. Number 1, you talk about pull force. It's too short an answer when they ask you to explain. You understand? So this part here have to be very, very careful. Okay, so you actually need to look at the question very carefully. Do you know how springs work? Yeah, because springs question will come out quite frequently. It's always about the elastic force. We always talk about spring and then we need to tell ourselves it's related to elastic force. So when will you have elastic force in a spring? Is it when it is in its relaxed normal length, normal condition? When the spring is in its normal, usual length, relaxed condition, is there any elastic spring force? Don't have, right? So yeah, that's correct. So Yashika says when it is stretched, Shoria says when it's stretched or compressed. So when it's compressed, what will it want to do? If you have a spring, I told you all before, right? Take out the spring from your old pen that you don't want anymore, you stop the ink, try to compress it. What will it tend to do when you compress it? You will want to push your fingers apart, isn't it? Correct? Yeah. And how about when you stretch it? Don't stretch all the way, stretch a little bit. You will also want to pull back again to its original length. So that is when you get your elastic spring force. Correct? So in this case, where can you see the elastic spring force? How many of you play with the packs before with spring? I did. Then I like to pull it out. Then after that, want to fix back. Very difficult, right? How many of you actually try to fix back? When you fix back, do you realize that the spring is always in a compressed state? Yes or no? It's not in a relaxed state, no? When you take it out, the spring is longer than it looked when it is inside the pack. Okay, don't know what I'm saying. I'm not too sure. Go and find one. Ask your mom for permission. Dismantle it. Take a look. Okay, so it will always be compressed. Because of that compression, there is elastic spring force. So you need to refer to that. How come it's here again? Who is the one go and play with all these things? See, now this one becomes frozen. Okay, try not to do that. Right, so look at 3. You don't talk about pull force only. Okay, let's look at Gallen's answer. He says when the handles are squeezed, a pushing force will be exerted on the compressed spring. When it is released after being squeezed, the compressed spring will exert elastic spring force. Okay, yeah, more or less, yes. Okay, exerts the elastic spring force where? Galen, you talk a lot about, how it happened when the handles are squeezed, etc. You didn't say anything about the compressed spring force, all right, pushing the handles to close the pad. You need to talk about it because you are answering this question about how to keep the pad closed, right? So you need to complete here. The compressed spring will exert elastic spring force where? On where? The spring will compress when the handles are squeezed. So bounce back when the handles are not squeezed. The grip will then grip the tower. The pad will then grip the tower. All right. Okay. Bounce back, Heidi. Possess. Okay. Can you change this to the spring will push the handles to close the pad? Something like that. It will be good. I know what you're saying, but the word bounce back is too extreme in this case. Okay, it's just a push over there. Elastic potential energy. Elastic potential energy. Ian, can you let me know something about this? What do you mean by elastic potential energy? Huh? Where's Ian? Is Ian here? Let me see. Where's his face? Too many of you. I have to find it. Yeah, okay, Ian, I see you now. You got the space behind you. Okay, do you know when will you have elastic potential energy? Yes, right. But do you think in terms of this question, you'll be given any mark? Why not? You read the question again. Anybody knows also can type into the chat. Why is it that he's not going to get? See, Galen already written down. Okay, Ian, I want to see whether you know. Not answering the question. What is the question asking you for? What is the question asking you for? Asking for forces. Yes. So many of them are telling me forces. He is talking about energy, not forces. Do you realize now? And you're not the only person who will do this. Many students will do this. They will answer questions on forces with energy and then vice versa. Yeah, so be very careful. Okay, so no need to even read. No, even let's say you wrote one whole paragraph on energy, nobody will read because it's totally out of point. Can? So this one I have to put red, but then I'm not putting because you are supposed to be writing your new answer here. Okay, so Joshua. Is Joshua here? Anybody see him? I think we are short of one person today. Yeah, it's Joshua. Joshua not here. Okay, now then I skip him first. Julian, the spring is compressed and has elastic spring force. Then my comment will be so. Are you teaching me anything about how come the pads can actually be closed? No, right? Okay. Exerts elastic spring force where? All right. Exerts elastic spring force where? Okay, now go on. I am lost. It holds the pad. Okay. Yeah, it keeps jumping. Maybe all of you just keep your if you don't have to change any answer, all of you do me a favor. Okay, go right down to the bottom right. Okay, up below Charmaine, you just put you just click on that box there. Otherwise, our columns will keep running. Can? I don't want to deny you access to this because I really need you to change the answer. All right, so yeah, let's try not to move this thing here and there. Okay. So Julian, talk a little bit about elastic spring force acting where, acting on what? Battle also. Okay, the compressed spring, yes, because remember I said, even the pack on its own, you leave it there already, it is compressed. The spring inside the pack is always in a compressed state. It's either more compressed or less compressed. Yeah, so it exerts elastic spring force on what? If it's our fingers pressing the spring, the elastic spring force is acting on our fingers, right? In this case, where is it acting on? The spring is pulling the pack. The spring doesn't pull the pack. The spring doesn't pull. The spring, in fact, is compressor, is pushing. It's the elastic spring force that's pushing outwards, right? Okay, to keep the handles like that. So when the spring is between the handle, okay, it is compressed already. So it's constantly pushing such that, it is keeping the pad closed. Can not pulling, Nabil. I must go and get a pad, I don't have it in my home. I don't have pads at all at home. I need to get one to show you exactly how it works. I probably can try taking a video. Let me think. Okay, just to let you all see and understand. Okay, it's closed by someone. The pack is always closed in its original state. It doesn't need to be closed by someone. That's why I am getting more and more worried as I read your answer. So Pranati, okay, go and explore the clothes pack if you have one at home. Okay, especially those with the spring, then you will know what I mean. Okay, so this question really need all of you to have access to it. You need hands-on. Okay, good. This one is good. Yeah. Yeah, Shaurya, you are changing. I'll wait for you. Okay, the elastic spring force. If you write these okay, pressing. Okay, is pressing, is pushing. On the handles of the pads. Yeah, keeping it close. Actually, this one will be very good. Yancy, I changed for you this time around. You owe me one lunch, okay? Yeah, so this is how you can write better. So if you want to start with elastic spring force, talk about it came from the compressed spring. Okay, and this force is pushing on the handles of the pegs, keeping it close. This is the shortest and the sweetest and straight to the point answer. Okay, Yashika, the compressed spring, all right, has an elastic spring force, okay, acting on the handles. Okay, you just need to add in the word acting. All right, let me add for you. Then it will be very good. Okay, the compressed spring has an elastic spring acting. Yes, this is good. So, oops. The rest of you, you see the answer that I added. As I added words for Yancy and Yashika. These are good answers. You may want to consider this. Okay, but don't copy word for word. Understand it. Try to see whether you can write on your own. I will read it again. Charmaine also, you wrote energy. Is Charmaine here? I'm sure Charmaine is here. I think just now I did mark her attendance. Charmaine, would you like to turn on your camera? Okay, so don't answer questions